Okay, all set. Our next contestant is OSullivan.
Hello, if you can hear me, I was hoping to tell you all about how the sound of my voice gets into your brain. Not just into your head, but that little step further into your brain. So my vocal cords are making little, oh, and plus this microphone is sending a sound signal as well through the sound system. That's a completely different format. We're not here to talk about that. So my vocal cords are making vibrations in the air, which are moving out towards your head, and they go into your ear, and that's banging on your eardrum, which is moving fluid all about, and that ends up making distortions in a little membrane inside your ear. We're going to call that the basilar membrane, because that's what it's called. And this basilar membrane has little hair cells on it that are the start of your brain. These are neurons. So your brain doesn't communicate in vibrations. One neuron doesn't push another like the air molecules do. Instead, these neurons communicate electrically, chemically. So a cell is like a bag of chemicals, and it's got a membrane covering the outside. You don't want to let too many things in and out unless you're communicating, unless you're changing things in the cell. And this is what neurons do to each other. They communicate, they send messages by changing little things. Inside this membrane, we have little, well, really complicated protein structures we call channels that let certain chemicals in and out. And these protein channels, there's lots of different types. My second favourite type is called the, electrically gated channel. And this means that it opens when there's a change in the electrical potential. So inside the cell there's these negative ions, and outside in the extracellular space there's more positive ions. So that makes a potential difference, a voltage across this membrane. And when this electrical potential changes, when the electrical potential drops, there's no longer this force pushing in, and so this electrically gated channel drops open, and in can flow some nice chemicals such as sodium. Let's get back to where we left off. The basilar membrane has little hairs on it. So how do you start off changing the electrical potential across the membrane? You get two little hairs and tie a piece of string from one to the other. There is, in these membranes, a tiny little protein strand that looks a bit like this, and as your protein membrane is shifting about, here's this mechanical gated channel that pops open a little gate and lets chemical in, and that's how it changes the start of the electrical potential and sends messages through your brain.
Thank you very much.